Many fish owners believe the scene is simple. A person approaches the tank. A fish turns, rises, and follows. It looks personal. It can seem as if the fish is recognizing a human presence in the same way a dog or a bird might. But inside an aquarium, behavior is rarely that symbolic. What looks like attention is often a chain of biological responses unfolding in real time. Movement detection, light contrast, feeding memory, territorial scanning, and constant assessment of a closed environment. Fish are not drifting through glass boxes without interpretation. They are reading patterns. They are measuring vibration, shape, routine, water flow, and spatial change. In that sense, what appears to be a quiet aquarium is actually a field of signals, and every pass near the glass becomes part of that field. Fish do not need a human concept of you to respond to you with consistency. They only need repeated sensory information linked to survival. Let's begin. At the glass. The most familiar behaviors are also the ones most often misread. A fish hovers near the front pane when someone enters the room. It follows a hand. It pauses and seems to stare. It darts upward when footsteps approach, or it vanishes into cover the moment a shadow crosses the tank. To a human observer, these moments look expressive. But from the fish's side, they are measurable reactions to nearby change. The front glass is not just a window. It is the boundary where external motion becomes visible, where shadows sharpen, where vibrations often arrive first, and where food has frequently appeared before. Repeated activity at that boundary turns it into a biologically important zone. Staying near the glass can signal anticipation, but anticipation is not the same as affection. Sudden dashes can signal a startle response, but not necessarily panic in the human sense. Hiding may reflect a fast calculation about exposure, not a dramatic change of mood. Many aquarium fish are constantly balancing visibility and safety. Open water offers access to food and information. Cover offers protection. So when a fish alternates between approaching and retreating, it is often expressing that balance through movement alone. Even stillness has meaning. A fish that freezes near the glass may be locking onto motion, conserving energy, or assessing whether a pattern outside the tank belongs to feeding, threat, or simple background noise. What seems like idle swimming is usually structured sampling of the environment. In a closed ecosystem, these repetitive behaviors become part of the fish's daily surveillance of survival conditions. Senses before meaning. Before a fish reacts to a person, it reacts to stimuli. Vision is one part of that process, but not the only one. Many species rely heavily on detecting motion, contrast, and changing light angles. Others also use the lateral line system, a network of sensory organs that detects low-frequency water movement and nearby hydrodynamic disturbance. A hand tapping the stand, footsteps on the floor, a lid opening or water shifting near the surface can all enter the fish's world before a face is clearly resolved. That is why some fish seem to know someone is present before the person even reaches the glass. Biologically, the fish is not receiving a social message first. It is receiving mechanical and visual cues that predict a possible event. Feeding changes these cues even further. Once food has arrived from above or from the front often enough, the nervous system begins linking specific signals to reward. Light shifts at a certain hour. A silhouette crosses the tank. The lid opens. Surface disturbance follows. Over time, the fish begins reacting earlier in the chain before food is visible. This is not imagination or devotion. It is associative learning, shaped by routine and internal biological clocks. Research on fish feeding behavior shows that feeding responses are influenced by circadian rhythms and by external signals such as light regime, temperature, and oxygen availability. In other words, the fish is not simply reacting to a person. It is reacting to a pattern that has become physiologically meaningful. The owner may appear central in that moment, but the deeper driver is prediction. Food may be near, conditions may be changing, and the body prepares before the event fully arrives. Through water and glass. How then does a fish actually perceive the person outside the tank? Not as a human identity in the human sense. The view is shaped by water, glass, angle, and refraction. Optical research shows that visual stimuli crossing air-water interfaces become distorted and compressed according to physical laws such as refraction. Shapes shift, angles change, light transmission is uneven. What appears stable from outside the aquarium may arrive to the fish as a transformed image with altered geometry. So, when a fish orients toward a face, It is not necessarily seeing a face as humans define it. It may be tracking contrast regions, motion signatures, or a familiar visual arrangement entering a predictable location in the field of view. That does not mean fish vision is simple. Quite the opposite. Fish have strong visual discrimination abilities. Archerfish, for example, have been shown to distinguish among many human face images, even when obvious cues like color and head shape were controlled. More recently, wild sea bream were shown to learn which individual divers provided food, and could follow the correct diver when visual differences in dive gear remained available. When those visual cues were removed, the fish lost that discrimination. The pattern is revealing. Fish can learn repeated visual differences associated with outcomes, but that is not the same as assigning human social identity in a mammalian way. In aquarium terms, a person outside the glass may become a recognizable moving pattern, a source of routine, a recurring silhouette linked to feeding, or a large object whose approach predicts disturbance. The fish may distinguish one pattern from another, but biologically it is responding to cues, not to the human concept of personhood. The tank decides. To-no-fish behavior can be separated from the aquarium itself. The tank is not a backdrop. It is the active system shaping every response. Water quality, oxygen levels, flow, light cycle, available cover, temperature, and the presence of other fish all alter how a fish reacts to the same external person. A fish that eagerly approaches the glass in stable conditions may become withdrawn when oxygen drops, when the water chemistry shifts, or when chronic social pressure builds. Studies on fish behavior show that temperature, hypoxia, acidification, pollutants, and other environmental changes can rapidly alter activity, exploration, schooling, and threat response. In that sense, the fish is not answering one question at a time. It is integrating many variables continuously. Tank mates matter just as much. In social species, spacing and shoaling are part of information processing. Fish use visual cues and hydrodynamic sensing to track neighbors, avoid collisions, and maintain distance. Territorial species add another layer, because the front glass can become part of a defended boundary or a route of repeated patrol. So when one fish rushes forward as another hangs back, the difference may reflect social hierarchy rather than owner preference. A dominant fish may occupy exposed areas because exposure is less risky for it. A subordinate fish may delay its approach because open space near the front intersects with both food competition and territorial pressure. The aquarium compresses these relationships into a small volume, making subtle biological negotiations look dramatic from outside. Every approach to the glass is filtered through the chemistry of the water, the structure of the space, and the invisible politics between fish. Instinct, not human story. This is where many assumptions begin to drift away from biology. A fish that watches someone enter the room is not necessarily missing them. A fish that follows a finger is not necessarily playing. A fish that stays at the front after feeding is not necessarily grateful. Those interpretations are understandable because human observers are built to read intention into repeated behavior. But fish operate through a different framework: sensory filtering, learning, internal state, and survival value. Their actions can be consistent, even sophisticated, without being human-like in motivation. Research on fish cognition shows strong abilities in learning, decision-making, navigation, and pattern discrimination, but none of that requires turning fish into small human minds behind glass. The more precise interpretation is usually narrower and more interesting. A fish that rises at a familiar time is expressing temporal conditioning. A fish that tracks a moving hand may be responding to motion sensitivity and food association. A fish that flares or charges at the glass may be reacting to territorial perception, distorted reflection, or sudden intrusion into defended space. A fish that goes still may be switching from locomotion to assessment. Scientific reviews of fish behavior emphasize that behavior is an integrated output of the nervous system, responding to internal physiology and external conditions. That means the visible action is not a symbolic statement. It is the outer surface of a biological calculation. The mystery remains, but it changes shape. Instead of asking whether the fish feels about a human the way a human would, the better question becomes: which stimuli, which memories, and which environmental pressures are being translated into this movement right now? Repetition becomes pattern. Over days and weeks, aquarium behavior gains structure. Fish learn routes, feeding zones, safe shelters, and timing cues. Repetition narrows uncertainty. If the same silhouette appears before food, the response to that silhouette strengthens. If the same area of the tank is repeatedly associated with disturbance, avoidance strengthens. If open water repeatedly leads to no threat, boldness may increase. These are not abstract routines layered on top of instinct. They are instinct being refined by experience. The aquarium becomes a map of outcomes, and the fish keeps updating that map through repetition. Biological clocks reinforce this process. Many fish show daily rhythms in feeding and movement, with activity rising before expected events. That pre-feeding surge can look like excitement directed at a person, but physiologically it may be a timed anticipatory state linked to light cycle and prior reward. Individual differences also matter. Some fish learn a visual task quickly, others require more repetitions. Even in controlled face discrimination experiments with archerfish, learning rates varied across individuals. So in an aquarium, two fish in the same tank may not react the same way to the same person, for the simple reason that learning, stress sensitivity, hierarchy, and species-specific ecology differ. What the owner experiences as personality is often an overlap between individual variation and repeated environmental history. The pattern is real. The explanation is simply more biological than sentimental. What it is signaling. So, what is the behavior actually signaling? Often, feeding expectation. A fish approaching the glass at a familiar hour may be expressing learned anticipation tied to routine and internal timing. Sometimes, territory awareness. A rapid charge, flaring display, or repeated patrol near one section of the tank may indicate boundary monitoring or response to a perceived intruder. Sometimes, environmental discomfort. A fish that suddenly hides, breathes differently, reduces exploration, or changes schooling distance may be responding to altered chemistry, oxygen, temperature, or social tension. And sometimes simple curiosity in the biological sense, orientation toward a novel stimulus to gather information while balancing risk. None of these meanings require emotional projection to be important. They are meaningful precisely because they reflect the fish's ongoing attempt to regulate itself within a limited world. In that frame, the human standing outside the tank becomes something very specific. Not a human, as humans define themselves, but a recurring environmental event, a moving visual pattern, a possible food predictor, a source of vibration, a large object at the edge of the territory, a repeated part of the aquarium's sensory landscape. Fish may learn that pattern, distinguish it from others, and respond with impressive consistency, but the response is built from perception, memory, and survival logic. What appears simple from the outside is an active reading of signals from glass, water, light, neighbors, and routine. In a closed ecosystem, every movement has meaning, because every movement enters the biology of something already listening. What appears simple is often deeply biological. Fish are constantly responding to the environment, memory, and physical stimulus, even when the tank looks still. Understanding behavior begins with observing patterns, not projecting stories onto them. This channel explores the hidden behavior of aquarium life through science,